Hello my dear students, welcome to Math Examination Preparation channel. We already discussed Jacobians in the previous lecture. There we discussed Jacobians of two variables. Here in this video, we are going to discuss Jacobians with three variables. Suppose you have three functions like u equal to u of xyz, v equal to v of xyz, and w is a function of the xyz. Then the Jacobian of u, v, w with respect to xyz is again the determinant dou u by dou x, dou u by dou y, dou u by dou z, dou v by dou x, dou v by dou y, dou v by dou z, dou w by dou x, dou w by dou y, dou w by dou z. This is a 3 by 3 determinant. Now, let us go to a problem. If u is x square plus y square plus z square, v is xy plus yz plus zx, and w is x plus y plus z, then find the Jacobian of u, v, w with respect to x, y, z. So the Jacobian of u, v, w with respect to x, y, z, that is denoted by j, this is the determinant actually shown here, right? So directly we write the derivatives in place of dou u by dou x, dou u by dou y, dou u by dou z. What is dou u by dou x? Because u is x square plus y square plus z square. So dou u by dou x is 2x, dou u by dou y is 2y, dou u by dou z is 2z. 2x, 2y, 2z. Coming to the second row, it is partial derivatives of v with respect to x, y, z. So, what is v? V is xy plus yz plus zx. So, differentiate v with respect to x. Because we are differentiating with respect to x, the first term xy contains x. Here y is treated as constant. Derivative of x is 1. Okay. So let us do it here. Dou by dou x of xy plus yz plus zx. We are differentiating with respect to x. So in the first term, y is kept as constant. Derivative of x is 1 with respect to x. The second term has no x directly, 0. The third term has x and z is treated as constant. Derivative of x with respect to x is 1. So this is y plus z. Similarly, dou v by dou y, here we get y. So dou v by dou y becomes x plus z. Dou v by dou z becomes y plus x. Okay. And then third row is the derivative of and the partial derivatives of w, which is x plus y plus z. So again coming to dou by dou x of w, which is x plus y plus z, which is the first term has x, the derivative of x with respect to x 1, then 0, 0, so 1. Similarly, other two derivatives also 1 and 1. So if you take the determinant, if you find the determinant, what we get is everything gets cancelled and we get the answer as 0. Okay. You find the determinant, you will get the answer as 0. It's a simple determinant only. So that is why I left it. And coming to the next one, if u equal to x plus y plus z, uv equal to y plus z, uvw equal to z, then show that dou xyz by dou uvw equal to u square v. See, in this problem we are given three relations: u in terms of xyz, uv equal to this, uvw equal to z. But we are asked to find or show dou xyz by dou uvw. But what is xyz in terms of, we have to express xyz in terms of uvw first of all, right? Then only you can find the Jacobian of xyz with respect to uvw. So how to express this? We already know z is equal to uvw, right? So given that z is already given as uvw, right? Now we need to express x and y in terms of uvw. So from the second relation is uv equal to y plus z. Here we know z. So uv equal to y plus uvw, right? So we need y. Therefore it is uv minus uvw, which is uv into 1 minus w. So therefore y is uv into 1 minus w, right? Now from the first relation, u equal to x plus y plus z. What is y plus z? Y plus z is uv. Just replace y plus z equal to uv here, right? So that you can easily find out x. So from the first relation it is u equal to x plus y plus z, and you can write y plus z as uv. So from this we need x, u minus uv, u into 1 minus v. Therefore x is u into 1 minus v, y is uv into 1 minus w, z is uvw, right? So this is how we have to find out xyz. We have to express xyz in terms of uvw first of all, to find the Jacobian of xyz with respect to uvw. Okay. Now the Jacobian of the Jacobian of xyz with respect to UVW is, we know this, right? Dou x by dou u, dou x by dou v, dou x by dou w, because the first row is all about x. Okay. Dou y by dou u, dou y by dou v, dou y by dou w, dou z by dou u, dou z by dou v, dou z by dou w. These things we have to find out now from x, y, z. So what is dou x by dou u? We have to differentiate x with respect to u. What is dou by dou x of, dou by dou u of u into 1 minus v? Okay. Here, this is dou x by dou u, right? Dou x by dou u is dou by dou u of x is u into 1 minus v. Now we are differentiating with respect to u, so 1 minus v is treated as constant. Dou u by dou u is 1. So it is 1 minus v. So the determinant 1 minus v. And dou x by dou v, you differentiate this as dou by dou v of x. X is u into 1 minus v. We are differentiating with respect to v. U is stated as constant. Dou by dou v of 1 minus v. So u into, what is the derivative of, what is the derivative of 1 minus v with respect to v? 0 minus 1, because constant derivative is 0. Derivative of v with respect to v is 1, right? So it is minus 1 minus u. And coming to dou x by dou w, there is no w term, w factor or w term, or there is no term related to w in x. Okay. X is u into 1 minus v. So therefore, the derivative is 0. Dou x by dou w is 0. Next, coming to the second row is all about y. Dou y by dou u. What is y? uv into 1 minus w. So dou y by dou u means we are differentiating this with respect to u. So v into 1 minus w is treated as constant. Dou u by dou u is 1. So v into 1 minus w. Similarly, dou y by dou v. Dou y by dou v means what? We are differentiating with respect to v. So u into 1 minus w is treated as constant. Derivative of v with respect to v is 1. Now dou y by dou w is dou by dou w of uv into 1 minus w. Here we are differentiating with respect to w. uv is treated as constant. Derivative of 1 minus w is 0 minus 1. Constant derivative is 0. Derivative of w with respect to w is 1. So minus uv. Coming to z, the derivative of z with respect to u. So what is z? Z is UVW. Z is UVW. Dou z by dou u means you are differentiating z with respect to u. With respect to u. So VW is kept as constant. Derivative of u with respect to u is 1. So it is VW. When you differentiate with respect to v, we get UW. Differentiate with respect to w, you get uv. Okay. So this is the determinant. We have to find out this determinant. It is 1 minus v into u square v into 1 minus w. So minus and minus plus u square vw plus u into uv square into 1 minus w minus and minus plus uv square w plus 0, because this is 0, we get the third term as 0. So when you simplify this, 1 minus v into u square v minus u square v w plus u square v w plus u into uv square minus uv square w plus uv square w. Okay. So this and this is cancelled. Here is cancelled. 1 minus v into u square v plus u square v square, which is u square v minus u square v square plus u square v square. Again, these two are cancelled, so it is u square v. So therefore, the answer is, the Jacobian is u square v. Next, this is a different type of problem. If u is x square minus 2y square, v is 2x square minus y square, where x is r cos theta, y is r sin theta, then show that dou uv by dou r theta is 6r cube sin 2 theta. See, this is not a 3 variable function, but this is actually, this problem is related to second property of Jacobians, which is chain rule. Because u and v are functions of x and y, and x and y are functions of r and theta. So you are asked to find Jacobian of uv with respect to r theta. We have to use chain rule. First you find Jacobian of uv with respect to xy, and then Jacobian of xy with respect to r theta, and then multiply these two, you get this answer. Now, here u is x square minus 2y square, v is 2x square minus y square. So dou uv by dou xy becomes dou u by dou x. That means we have to differentiate u with respect to x. Second term there is no x. So derivative of this is x square, derivative is 2x minus 0. Dou u by dou v, dou u by dou y. With respect to y, when you differentiate, first term has no y, so derivative is 0, minus 2 into y square, derivative is 2y, so minus 4y. Okay. Then dou v by dou x is 4x, dou v by dou y is minus 2y. So when you multiply, what you get? Minus 4xy plus 16xy, which is 12xy. Now coming to the second part, this part is over. The second part, we are given x equal to r cos theta, y equal to r sin theta. Right? Need to find dou xy by dou r theta. This is dou x by dou r. That means differentiate x with respect to r. So theta term is constant, which is cos theta is constant. So differentiating with respect to r, cos theta is constant. Derivative of r with respect to r is 1. Okay. And then dou x by dou theta. Differentiate x with respect to theta. R is constant. Derivative of cos theta is minus sin theta. Similarly, derivative of y with respect to r is sin theta into 1. Derivative of y with respect to theta is r cos theta. So this is r cos square theta plus r sin square theta, which is r into sin square theta plus cos square theta is 1. So it is r. Therefore, dou uv by dou r theta can be written as dou uv by dou xy multiplied by dou xy by dou r theta. How it is possible? Because of chain rule. So this is 12xy into r. Either we have to convert everything into r theta or everything into xy. So answer is given in terms of r theta. So 12 into x is r cos theta, y is r sin theta into r, this r. So 12 r cube sin theta cos theta. So you can write 6 r cube. Remaining you will be having 2 as a factor. So 2 sin theta cos theta is sin 2 theta. Remaining factor is 6 is written here. Okay. Coming to a different problem. If u equal to yz by x, v equal to zx by y, w equal to xy by z, then show that dou uvw by dou xyz equal to 4. See again, this is a 3 variable problem. 3 variable Jacobians we have to find. So here dou uvw by dou xyz is a determinant, right? Dou u by dou x, dou u by dou y, dou u by dou z is first row. So let us find dou u by dou x. It is dou by dou x of u. U is yz by x. Because we are differentiating with respect to x, yz is constant. So dou by dou x of 1 by x. You can take yz as common, right? You can take it out. So yz into derivative of 1 by x is minus 1 by x square into derivative of x with respect to x is 1. So minus yz by x square is dou u by dou x. Next, dou u by dou y. Dou u by dou y is dou by dou y of yz by x. Now we are differentiating with respect to y. So z by x is constant. You can take it out. Dou by dou y of y 1. So z by x. When you differentiate u with respect to z, we take y by z common this time. Derivative of z with respect to z is 1. So it is y by x. Not y by z, y by x. We take y by x common. The remaining is z with respect to z. The derivative is 1. So y by x is the remaining factor. So z by y, similarly if you find the remaining 2, you get z by y minus zx by y square x by y. Third row, it is dou z by dou x, dou w by dou x, sorry. Dou w by dou x is y by z, x by z, and then dou w by dou z is minus xy by z square. So if you simplify this, actually you can take 1 by x square, 1 by y square, 1 by z square from the determinant, and you can write it as minus yz, zx, yx, azy, minus zx, xy, yz, xz, minus xy. So if you simplify this determinant, you will get 1 by x square, y square, z square into minus yz into x square yz minus x square yz. Right? Both are cancelled. Minus xz into xz or zx, whatever, into minus x y square z minus x y square z plus xy into xyz square plus xyz square. So in the first one it is cancelled, 1 by x square, y square, z square into, it is minus 2 xy square z into xz. So into minus xz. So it becomes plus 2x square y square z square plus 2x square y square z square, which is 4x square y square z square by x square y square z square, which is 4. Right? So that is the answer required. Okay. So one more problem. There is the last problem in this second part of Jacobians. This is somewhat important and a different problem. X equal to r sin theta cos phi y equal to r sin theta sin phi, z equal to r cos theta. Suppose you are given three functions. Here three variables x, y, z are functions of r, theta, phi. So you are asked to find or show that dou x, y, z by dou r, theta, phi is equal to r square sin theta. This is very important problem. So you can also see this problem in a different way. Like this can be asked like transformation of volume elements between Cartesian and spherical polar coordinate system. Polar coordinate systems. So you may be asked the problem in this way also. Then, so what you have to do is dou xyz by dou r theta phi is a determinant again. Here x is r sin theta cos phi. So dou x by dou r, the first thing is dou x by dou r, right? So dou x by dou r is dou by dou r of r sin theta cos phi. But here we are differentiating with respect to r. So sin theta cos phi is constant into derivative of r with respect to r is 1. Therefore, it is sin theta cos phi. That is the first one. Similarly, the next one is dou x by dou theta, right? Differentiate x with respect to theta. So r and s cos phi are constants. Derivative of sin theta is cos theta. So r cos theta cos phi. The next one is dou x by dou phi, right? Dou x by dou phi. Now differentiate x with respect to phi. R and theta are constant, so r sin theta is kept constant. Derivative of cos phi with respect to phi is minus sin phi. Similarly, derivative of y with respect to r. What is y? Y is r sin theta sin phi. Y is r sin theta sin phi. So derivative of r sin theta sin phi with respect to r. Then we keep sin theta and sin phi constant, right? So sin theta into sin phi. Derivative of r with respect to r is 1. Now differentiate y with respect to theta. Then r and sin phi are constant. Derivative of sin theta is cos theta. So r cos theta sin phi. Then differentiate with respect to phi. Differentiate y with respect to phi. R sin theta is constant. Derivative of sin phi with respect to phi is the cos phi. Now what is z? Z is r cos theta. Z is r cos theta. There is no phi term in this. So dou z by dou r is cos theta. Dou z by dou theta is minus r sin theta. Dou z by dou phi. There is no phi in this. So 0. So if you simplify this determinant, what we get is sin theta cos phi into 0 plus r square sin square theta cos phi minus r cos theta cos phi into 0 minus r sin theta cos theta cos phi minus r sin theta sin phi into minus r sin square theta sin phi minus r cos square theta sin phi. Okay. So you simplify this, what we get is r square sin cube theta cos square phi plus r square sin theta cos square theta cos square phi plus r square sin cube theta sin square theta phi plus r square sin theta cos square theta sin square phi. Now you take the first this term and this term. You take r square sin cube theta common. Then we get cos square phi plus sin square phi, which is 1. Plus in the remaining two, this and this, you take r square sin theta cos square theta common. The remaining is cos square phi plus sin square phi, again it is 1. Now r square sin square theta you take common. Sorry, r square sin theta you take common. We get sin square theta plus cos square theta, which is 1 again. So answer is r square sin theta is the answer. This is what we need to prove. Right? Thank you. This is second video on the Jacobians. The next video will be on functional dependence and independence. Okay. Thank you.